Hello everyone and welcome. In this video, we'll be looking at how to represent signed numbers. We'll see how negative integer numbers can be represented using sign and magnitude. There is another method which I'll be showing you, that's using 2's complement, but we'll focus now on just using sign and magnitude. Now, sign and magnitude, it's a very easy way of representing signed numbers. But one of the issues with sign and magnitude is the fact that it doesn't work very well when we try to complete arithmetic operations using those values. And I'll show you proof of that towards the end of this video. When working with sign and magnitude, one thing you should remember is that the most significant bit is the sign bit. Okay? Now, if that most significant bit is 1, it means that we're working with a negative number. If the most significant bit is 0, then the value we're working on is a positive number. Now let's look at examples. Let's say, for example, we are asked to convert minus 24 to binary using sign and magnitude. What you want to do first is to write down our number sequence. So I'm just going to write down here 1, 2, 4, 8, 16, 32, 64. Now I know 24 will fit in comfortably into an 8-bit. However, our most significant bit here is our sign bit. Now I know this is a negative number. It therefore means that my sign bit is going to be 1. So I'll put 1 there. I will then need to convert 24 now to binary. And we know to do that, we just check, is 24 equal to or greater than 64? It's not. I'll put a 0 there. Is 24 equal to or greater than 32? Is not. I'll put a 0 there. Is 24 equal to or greater than 16? It is. So I'll put a 1 there. And I would say 24 minus 16, which gives me 8. Is 8 equal to or bigger than 8? It is. So I'll put 1 there. I'd say 8 minus 8, which gives me 0. And technically, these other values there will be 0. So it means that minus 24 to binary using sign and magnitude is 1, 0, 0, 1, 1, 0, 0, 0. This is our final answer. So this is minus 24 using sign and magnitude. Let's look at another example. In this example, we will be converting minus 107. Again, I'll write down my number sequence. I'd say 1, 2, 4, 8, 16, 32, 64, and the final bit here is my sign bit. Looking at minus 107, we know the sign is negative, and if it's negative, we've said it has to begin with 1, so put the 1 there. And we convert 107 to its binary value. So 107 is bigger than 64, so I'll say 107 minus 64, so I'll put the 1 there. 107 minus 64 gives me 43. 43 is bigger than 32. 43 minus 32 gives me 11. 11 is smaller than 16. I'll put a 0 there. 11 is bigger than 8. I'll put a 1. I'd say 11 minus 8, which gives me 3. 3 is smaller than 4. I'll put a 0 there. 3 is bigger than 2. So I'll put a 1 there. And I'll say 3 minus 2, which gives me 1. 1 minus, equal to is the same as 1, so I'll put a 1 there. 1 minus 1 gives me 0. It means I have to stop. So this therefore means that minus 107 to binary using sign and magnitude is 1 1 1 0 1 0 1 1. In our final example, we're going to be looking at, so in the third example, let's look at plus 27, otherwise 27. Okay, to do this again, I'm going to write down my number sequence 1 2 4 8 16 32 64, and then my sign bit. Now the sign here is a positive value, which means it should begin with 0, and then we convert 27 to binary, and I know to get 27 I only need the numbers 16, 8, 2 and 1. Okay, so 27 using sign and magnitude to binary is 0 0 0 1 1 0 1 1. See, it's so easy to convert values using sign and magnitude. Now when you have sign and magnitude, when you're working with sign and magnitude and your key focus is on 8-bit values, 0 can be represented in two ways. So 0, the number 0 can be represented as all zeros, or like this. 1 2 3 4. So it can be represented as all zeros, or like this. So technically what I'm trying to say here is this is minus 0. Now again, with sign and magnitude, the minimum negative number you can have is minus 127. That's the minimum negative number you can have. And the maximum the maximum positive number you can have is plus 127. So technically speaking, if we convert this value, minus 127, in sign and magnitude, we would have 1, which is our sign bit, and then all ones. Okay, and for plus 127, we would have 0, which is our sign bit, and then all ones. Now, you may be asked in your exam to convert a sign and magnitude value to denary. To do that, the first example we're going to look at here is 1 0 1 0 1 1 1 0. To do this, all you have to do again is just write down your number sequence. Some people don't have to do this, but I think it helps. It shows that it allows you to show your working, and then it's just easier for you to see, for you to solve the problem. So if I do 16, 32, 64, I'll write down my sign bit here. Now, if you remember, we say that the most significant bit, that's this number here. If it's 1, it means it's a negative number, and if it's 0, it means it's a positive number. So what I'm going to do here is, I know if I write the number sequence out here, 1 0 1 0 1 1 1 0. So if I write down my binary number then under the number sequence, this I know it's a negative number. So all I have to do next is to find the key value there, which will be 32 plus 8 plus 4 plus 2. And this will give me minus, for this negative there, 46. Let's look at another example. In this example, we're going to solve 1 1 0 1 0 0 1 1. We're going to convert this again to denary. So it's a sign and magnitude value, which we're going to be converting to denary. I'll write down my number sequence again. 1 2 4 8 16 32 64, and then we know the most significant bit is our sign bit there. I'll write down the binary number under my number sequence, 1101 0011. Once again, I know that this is a negative number, so I'll put my negative sign there. And then I know I have to say 64 plus 16 plus 2 plus 1, and this gives me minus, for that negative value there, 83. Let's look at another final value here. So if we look at our third example, if we look at 0 0 0 1 1 1 1 0, again I'll write down the number sequence. 1 2 4 8 16 32 64, and then I know that my most significant bit is a sign bit. In this case, the sign bit here is a positive number, indicates a positive value. Let me write it down underneath here, so I know we have 0 0 0 1 1 1 1 0. I know it's a positive number there, and I know we have 16 plus 8 plus 4 plus 2. And if we add all of this together, we will get plus 30, or you can just say 30. Now, at the start of this video, I highlighted that sign and magnitude does not always support operations with signed values. So let's look at this example here. Let's try and demonstrate that. If we look at this example here, let's say, for example, we have minus 83 plus 30. If we're asked to solve this problem, minus 83 plus 30. To represent minus 83, I know that minus 83 using sign and magnitude is 1 1 0 1 0 0 1 1, and 30 is 0 0 0 1 1 1 1 0. Okay, so this value here represents minus 83, and this value here represents plus 30. If we add these numbers together, we get 1 plus 1 is 0 carry 1, 1 plus 1 is 0 carry 1, 1 plus 1 is 0 carry 1, 1 plus 1 plus 1 is 1 carry 1, and then we have 1 there, and then we have 1, 1. If I add all of these, if I convert this value there, I get minus 1, 1, 3. And I'm sure you're looking at this at home and going that this is incorrect. It is wrong. To solve a problem like this, we would have to use 2's complement method. Okay, we'll have to use 2's complement method. It is a better way of representing negative numbers, especially because it works very well with arithmetic operations.